Hello, my name's Duncan Butler. I'm from the Primary Standards Dosimetry Laboratory, which operates out of Arpanza in Melbourne, Australia. This is just showing our location down here in Melbourne. This is a picture of the lab and pointing out that we're one of 3 organisations that does primary standards work in Australia. We just do radiation dosimetry. I'm going to talk to you about a way of producing a digital calibration certificate from an Excel file. There's an example which hopefully you can get attached with this presentation, and one of the key things of doing this is that I've included a way of creating a PDF and embedding that in the DCC. And that might be useful if your clients are not demanding a DCC. In our case, they're probably going to want the PDF for quite a while. We're using Visual Basic for applications. That's the language that comes with Excel that you use for macros and scripts. So this shows what we're aiming for in our laboratory is nearly fully digital process. The only manual step here is connecting up the equipment, but after that, the measurement results should be obtained automatically. There's a database and administrative data is entered into that. And one of these systems can produce the DCC using all of that digital information. That's not what we have though. That's what we're aiming for. What we have has some of that. In fact, we do use computers to read the equipment directly, but there are other steps in that there are data files that have to be selected, put into Excel, information has to be typed into Excel, and then we produce a PDF which we give to the client. You can do that in Excel. It's very straightforward. You just have an extra tab or worksheet that you format exactly how you want it, and then you can either print it to a printer, get a paper copy, or print it to a PDF. Our current process is to print it and then sign it in pen, scan it back to PDF, and email it to the client. And this is not a great system. So if we could move to a DCC, we're hoping that we can remove that print and scan step. And that's particularly important at the moment when we're working remotely. We literally cannot get people in to sign, and we often have a couple of people sign the reports. We also get a better quality PDF if we can not have to print it and scan it. And of course we get all the benefits of a DCC. It's machine readable, unambiguous, see the other talks. I view it as an interim solution in that I'll talk more about this later, but Excel is probably not the future for making DCCs. I think it would be useful if you already use Excel to produce reports, and it's easy if you've got no other way of making a PDF and you need one, because creating the PDF is very easy, as you'll see. And we have customers who I think would prefer a PDF because they don't know that they need a DCC yet. I think once they get used to them, they will realise that they do want a DCC, and they'll be happy to ignore the PDF. But there'll be quite a long overlap period. So this is the example. It consists of 6 worksheets, and you work from left to right. The first one is just information about the sheet. The second page is, it's got reference number. It's all the administrative data, the name of the client, their address, dates, instrument serial number, and the names of the people who are going to sign the report. And I'll just note that because it's Excel, you can force the format of these fields. They don't have to be text. The dates could be dates, for example. Measurements is the actual results of the calibration. And again, they're typed in by hand in this case. And the fourth tab is the report. And this is what I showed you before. You could print this on a printer, or you can use it directly as a PDF. And the fifth tab has a button which will run the macro or the script that will produce the DCC. So it has some cells that hopefully identify the file names. I haven't tested this on all versions of Excel, but it certainly works on the Australian version. It picks up the directory, the name of the current file, and then it tells you what it's going to produce. It's going to produce a PDF, this text file, and the DCC itself. So what happens when we run that? Well, this is before and after, and it created these 3 new files. This is looking at the PDF file that was created, and it looks like a calibration certificate. The results are on the last page. It's got some other information from the client, the laboratory logos and other markings. You can put anything in this, graphs, pictures. Then we look at the DCC, which is a text file. So I've opened it in Notepad just to show that you can do that. It's a bit hard to read in Notepad because it's all the same color. I don't think it opens in Word very well because Word tries to interpret it. But the best way to open it is in Notepad++, which I've done here. And then you can use this plugin, XML Tools, and you can validate this against the PTB schema. And that means if there are no errors, then it is a DCC. Here is the PDF encoded as base 64 characters, so it just looks like random characters. But there is the PDF data hidden away in the back, at the back of the DCC. Okay, so the script to create the PDF file is literally one line. It's really easy. It's this command here. You just set the worksheet and export it as fixed format, and you give it the file name, and it's done. Here's writing the DCC. Now there was one quirk of using VBA to write it, in that the DCC needs this character, the double quote, and that requires a bit of care in VBA. So I just found by experiment that this would let you print stuff with quotes around it, but it has made the code look pretty ugly, and there's probably a better way to do it, but I'm not a VBA expert. But that is how you write the DCC. Next page. This is how you take the PDF file, which is here, and you open it as a binary file, and with this code, which I just found using Google, I honestly don't know what it does exactly, but it will encode that binary data as a series of characters, and then you just have to save that into the PDF, into the DCC. For interest's sake, I've printed it out as a text file, which is this last step, but you don't need to do that at all. And here is the line of code in the script writing the PDF characters into a field at the end of the DCC, and then you just close the DCC, and that's it. Of course, the person receiving the DCC may not want to use it directly. They might be old school and they want to see the PDF, in which case they have to extract it. And I'm sorry, I couldn't get it to work in Excel. I'm sure it's possible, but I tried for a while, and I just went to using Python because it's very easy in Python. And I've included the Python script on the last tab of the worksheet. Here's an example of it. You just type Python, the script name, the DCC name, and the extracted PDF. And it produces this, and you can see it's the same size as the original one that was used to create the DCC. And if you open it, it looks like a PDF calibration certificate. So finally, what's good about this? Well, Excel's familiar. Most people have got it. And I think it's useful if you already use Excel to make reports. It's very easy to make and embed the PDF. So if you don't have IT expertise, or you're a small laboratory, it might be the way to go for making that PDF. I've just got an aside though that the PDF is also a kind of CRC check in that it can be very hard. It would be quite difficult to change the data in the DCC and also change the data in the PDF because that's all encoded. So it does give you a level of protection against accidental changes. It's not a security thing, but it's going to stop someone accidentally changing a number in the DCC, and the user can always check against the PDF. Cons, I found VBA not very easy for writing these long text files. And in my code anyway, if you added a new line in one of the spreadsheets, all the references would no longer point to the correct cells, like they don't follow. They essentially don't change their reference numbers. And I think it's not the future because Excel, all those yellow fields had to be filled in by hand, and it's not easy to automate filling them in digitally. And I think the future, those fields will be filled in digitally. And also spreadsheets are full of errors. They're surprisingly complex and they're full of unusual references, and yeah, there have been surveys of spreadsheets that have shown many of them have errors. Very hard to validate fully. So finally, key things about this example, the DCC, it's not complete. It doesn't contain all the data that is in that spreadsheet. I didn't finish it, basically. It's for demonstration only how you do things. And I'm sure everyone involved with the DCC would like you to make sure that if you are going to embed a PDF in the DCC, they should both use the same source of data, which they do in this case. They're all coming from that yellow fields. You don't want to have different data going in. And of course, you need to check the DCC that comes out of this and validate the script, just like any software. It's bound to have errors. Okay,